Okay, so the last section we're going to do in this unit is hyperbolas. If we had more time, we would go on and talk about how to rotate the ellipses and hyperbolas so that they're not just vertical or horizontal. Yeah.
I actually lost it already.
Did you go get it?
No, Ben got it. I saw it.
Here's the definition.
That what?
It's the set of all points such that the absolute value of the difference in distance from two fixed points, again those are the foci, is constant. So it's actually the exact same definition as an ellipse. The only difference is literally the word difference. Instead of the two distances adding up to the same thing, now when you subtract the two differences, they're always going to equal the same thing. Okay, so we'll just get right into it here. Here's what a hyperbola that opens in the x direction looks like. And I'm going to actually construct this hyperbola the exact same way that you should construct any hyperbola.
A box.
Yeah, first do a box.
How big does the box have to be?
Doesn't matter right now. Or I call it sometimes a reference rectangle. Okay. Bless you. Now, the distance from the distance from center to one end of the rectangle is going to be A. And the distance from center to the other end of the rectangle is going to be B. And then after you draw this rectangle, I would always go through the diagonal and draw asymptotes, dotted lines that go through the corners of the rectangle. So in other words, just extend the diagonals of the rectangle. Okay, and the slopes of the asymptotes are always going to be plus or minus. In this case, it's A over B, or I'm sorry, B over A, because it's rise over run. I'm just going to always write it as RY over RX.
What?
Radius in Y direction over radius in X direction. Sometimes it's B over A, sometimes it's A over B. It depends on which way the hyperbola opens. But if you always remember it as the rise over the run of that from center to corner of the rectangle, that's really all you need to know. Okay? And now, the actual hyperbola, wherever A is, that's where you draw the vertices. And you just draw what looks like two parabolas that get closer and closer to the asymptotes on each side. So this is what the hyperbola looks like. And now here are the equations that you need to know. Instead of d1 plus d2, now we have the difference in d1 and d2. And we put absolute value around it because depending on the order, it may or may not be negative. But it's still going to be 2a. For ellipses, what was c squared equal to? Here it's a squared plus b squared. And I see some of you remember. Or that was a good educated guess.
That was nice.
Eccentricity is still c over a. Okay?
What is z? What?
What's what?
Is it z or 2?
It's
2. Okay. For an ellipse, we said that from vertex to vertex was called the major axis. Okay? We call that the transverse axis.
Which one is that one?
From vertex to vertex. And in this case, how long would it be? 2a.
Oh, you did. Good job.
So the transverse axis is this green one here. If I drew in this one here, then we call that the conjugate axis. And that's going to equal 2b. It's kind of like the minor axis for an ellipse. Best way to think about this is here we have a hyperbola that opens in the x direction. If this hyperbola were to open in the y direction, this is where the vertices would be, and this is exactly the same picture. It's just we'd have opening up and down. Okay? Let's see. The equations. You have two options. I'll write them both down. X minus h squared over a squared minus y minus k squared over b squared equal to 1. Or y minus k squared over a squared minus x minus h squared over b squared equal to 1. These are the two types of equations for hyperbolas. Depending on how they're written, it tells you exactly which direction the two branches open. Okay? And the easiest way to remember that is just to look at what's positive. So if I'm asking you in this first one, what's positive here, you would say what, x or y? So since the x term is positive here, we say that this opens in the left and right direction, sideways. Okay, and here in the second equation, you see how the y term is positive now? So that's how we know if it opens up and down.
It's a song. Euro song. It's on yoga.
Are there any questions so far?
No.
Okay. Then let's do an example. We'll skip the easy one. We'll go right to a one where we have to complete the square, find all the details.
You think we're ready?
I think we're ready.
You think we're ready?
Okay. So we're going to find vertices, foci. Oh, speaking of foci, sorry, go back to the picture. Forgot to label them.
Nope.
Where would you guess that the foci are going to be?
In the middle.
Yeah, on the inside of each branch. So here's one focus, here's another, and this distance is C. Okay. So all the letters A, B, and C pretty much mean the same as before. Picture's a little different. All right, let's see what happens when we work through a problem here. So we want to find the vertices, foci, eccentricity, transverse, and conjugate axis length, and asymptote equations.
How did I call eccentricity last time? Elasticity, right?
Here's the equation. 9y squared minus 54y minus 25x squared plus 200x minus 544 equal to 0. Looks exactly like the problems from over the weekend with the ellipses. The only difference is we have a y squared but then a negative x squared. Okay, so right there you're going to know it's a hyperbola. We don't know if it opens up or down yet because the negative and positive could switch. Yes?
Can we write down what we need?
What do you mean?
You know, like A, B, C, or like 4, 5, 8.
Well, it says right here, vertices.
Can you
Foci.
write it down?
I'm getting there. I'm getting there, John. Generally, yes, you do want to write down what you need, and we'll get there as soon as we're ready. First, we need to complete the square, though. If you take out a 9 from the y's, what do we get?
Y squared minus 6y.
Magic number is good. So take out a negative 25 from the x terms. We get x squared minus, very good, 8x plus 16.
Wait, what happens if they don't factor out? Is there a problem?
We force it. We make a fraction if we have to.
I don't like forcing it.
Okay. So we add 544. What do I add from this term?
881. Yeah.
And now from here we subtract because we have a negative times a positive. And what is that? 400?
I'm guessing 400.
Yeah.
I got you.
Why did you underline?
Just in case people were wondering where we got 81 and negative 400 from. What's that?
225.
Is that what you get?
Yeah.
So 9 times y minus 3 squared minus 25 times x minus 4 squared, and you said it's 225?
Yeah, that's what I got.
All right.
I
So
got you the other ones too.
divide by
225.
225.
That over 9. Oh no, over 25. And then the other one's over 9.
Thank you. And what's this last one?
1.
Okay, just making sure.
What are you trying to say?
Let's write what we need to know.
What?
Let's write what we do know so far. How's that?
Right, let's do A.
A is what?
A
25.
is 3.
3. 5.
A is 3.
5.
And then Y, and then B is 5.
A is 5, my buddy.
No, it's not. A is.
A is 5.
Okay, let me ask you a question. Which direction does this hyperbola open?
It opens up
Left and right.
Up and down.
What you mean open down? Into Y is bigger, man. Look at the minus.
Where's
Yeah, wait. If the Y is bigger,
It'll go up and down anyway.
Come on, man. Let's get
Yeah, there's 2 strikes against you. I just want to make a point here. It doesn't matter which of these is bigger. It's all that matters is which is positive. That's where the A comes from.
I think
Y
we
is
call
positive.
them
So what?
So A comes from the 25. So A is 5
Then how come on the other ones Y was B?
because it was
because it opened in the other direction. Okay. B is in what in this one?
3.
3.
So this is the opposite now?
What do you mean opposite?
These, they're the opposites.
Okay.
What are you doing?
hold on. For ellipses, A is always the what?
X.
A for ellipses is the big
It's the biggest one for ellipses. For hyperbolas,
The first
it's whichever one is underneath the positive term.
Okay.
Wait,
It doesn't matter if it's bigger or smaller. Yes.
wait, since you said like the positive one, like, well, we see one that's like negative x minus 4 squared over 9 plus y minus
Yeah, you could see it that way.
Wait, can
I
you-
usually like writing it like this because I don't like putting a negative in front.
Can
But
you explain what you just
It's not
said
really
again?
A is always with the positive term.
Z is root 2.
Okay. Yes.
So for a hyperbola, there's always a subtraction sign, and for an ellipse, it's plus.
Yes.
Okay.
Yes.
I love
Okay.
Who is that?
So here we get C is root 34, right? What's the equation for C squared?
Oh.
A squared plus B squared. So C squared is going to be 25 plus 9, right?
Is it? Oh yeah.
Yeah.
I forgot it was plus and not minus.
Yeah.
Right, according to my calculations, it's 34.
Yeah.
Yeah. It's pi over 2 3 pi.
Okay. Let's draw a picture, and we'll answer all these questions that we needed to answer. Where's the center?
Center is at 3 4.
Almost.
4 3.
4, 3.
That's the center. Move 5.
1, 2, 3, 4. 1, 2, 3. So here's the center. First, draw your rectangle. Yeah. The 25 was under which letter? Y. So we're going to go up and down 5. And then in the x direction, how far do I go? 3, right? So 3. And now you just make a rectangle using those points.
How much did you go off?
5. Because underneath y was 25. 1, 2, 3, 4, 5.
Oh, from the center.
From the center, yes.
Center.
Why do you go left and right?
Because 9 was underneath the x term. So that's 3 in the x direction. Okay? Any questions on where these numbers are coming from and how we drew the rectangle in?
Why is. Oh, no. The opposite.
Okay. Next, drawing the asymptotes. Asymptotes are just the diagonals of this reference rectangle. And we said that this hyperbola opened up and down. So it's going to look something like this. The foci are somewhere here. We'll find those coordinates in a minute. We'll find everything, yeah. I'll just go in order of the problem. First it said, where are the vertices? The vertices are right here. These points, right? What were the coordinates there? 4, 8, and 4, negative 2. Foci. I didn't write the coordinates down, but we've already calculated how far the center is to the focus, right? That's root 34, right? That's your C. So what are the coordinates of the foci? What are the x coordinates?
4.
No matter what, either one, x is 4.
34 plus or minus.
And now what we're doing is starting at the center and going up root 34 and then going down root 34. So what's the y coordinate of the center right now? 3, and then we're going up and down root 34.
Miss G.
Yeah.
Alright, I get everything besides when you drew in the full size and
What does C represent?
this represents the distance between the center and some foci.
Which we figured out is root 34. Hey,
So C is the foci?
it's not it's the distance to the foci.
Yeah.
What's up?
That's already asked if we get extra credit if we dress up for casino day.
I'll consider it.
Yeah?
I'll consider it.
Okay.
Okay.
Just give her an A, Mr. G.
Just give her an A.
Yeah. Give me an A.
Okay, so we good, John, where we got this?
Yeah.
Okay.
So
Next.
we already got 4, but now what about 3?
Well, because we started at the center, which has a y coordinate of 3, and then we went up root 34, and we went down root 34. So that's what this means. Starting at y equals 3, we go up and down root 34 to get to the foci. Okay? What's next? Eccentricity. C over A. So that's root 34 over A was 5. We did a few of these on Friday. Can you guys type this in and tell me what kind of number you get?
Accessible.
Wait, is that just insane?
Same formula, yep. So if you forgot it, it was C over A. What do we get when we do it in this case?
1.16.
1.16, right? What kind of numbers did we get on Friday for ellipses?
1.16.
Lower than 1.
Lower than 1. Very good. So if you ever have a problem, if you have an ellipse, the eccentricity should always be less than 1. If it's a hyperbola, it's always going to be greater than 1. Okay? Now, what else did we need?
You can tell the difference.
Yes, that's exactly right. And if we had more time, we'd talk about more properties. But as long as you know that much, that's fine. Okay? What else did we need? Transverse axis length.
Isn't that just 3?
Transverse axis is from vertex to vertex. How far away are these?
2A.
So that's
10.
10, right? Conjugate axis length is just the other width of the rectangle. How big would that be?
6. No, not 2B.
Very good.
Wait.
Conjugate axis is just the other dimension. The transverse is always 2A, conjugate is always 2B. Okay? And I think those are all the details we needed. Oh, asymptote equations, last one. We're not going to make this any harder than it needs to be. Okay? The asymptotes are here in light blue. What do we need to find the equation of the asymptotes? Well, 2 points is okay. Slope and a point is even better, right? Do I have 1 point that's maybe in common to both?
4 and 3.
So using point slope form, since the center is on both of these, I'm going to say that y minus 3 has to equal the slope of the asymptotes times x minus 4. You guys see where I'm getting this from?
Yeah.
Okay?
Rectangle, they should have the same slope, just opposite.
Exactly. So that's why I'm saying let's not make this harder than it needs to be. Just write point slope, and then we're going to write plus or minus, and then if you have a good picture, you could just count rise over run. Or if you remember how we graphed the rectangle, we went up and down 5 and over 3.
So is it just A over B?
In the, well, depends on which way it opens. In this case, it opened up, so that's why A. But if it opens sideways, it's B over A. Okay? Questions on this?
No, senor.
Okay, let's do a couple going the other direction. These will be quicker.
I ran out of paper. Okay.
Example. Find the equation of the hyperbola if the foci are at plus or minus 5, 0, and the vertices are at plus or minus 4, 0.
Right, don't tell us what to do. Just lead us in your direction.
How if you don't want us to tell you? You don't want us to tell you, but you
Don't tell me the answer, but just be like, alright, what would you do?
What would you do, John?
We're drawing what I know.
Drawing what you know, okay? 5, negative 5. 4, negative 4. Foci, vertex. Foci, vertex. So it looks something like this, right? You can find the center, yeah. Where is the center? Has to be 0, 0, either from your picture or if you look at the midpoint of plus and negative 5, 0, you get 0, 0, right? So let's write down A. Do we know A? B? C? Which ones do we know? We know A and we know C. From center to vertex is how far?
4.
So that's A. From center to focus is what letter?
C.
And what is that?
5.
And the equation, very good, is C squared equals A squared plus B squared. So 25 has to, and you probably know it if it
9.
has to be 9, right?
3.
So 3 for B.
Snaps.
And the only two things we need now for the equation are really A and B. And now we write the equation. Which way does it open? So what term is first, x squared or y squared? X squared, very good. And how far did I go in the x direction to get to the vertex?
So what are we doing?
So 16. And then minus, since it's a hyperbola, y squared, and then that's the b value, very good, and we're done. Okay? We'll do one more. Are there any questions on how we got this?
Yep.
What, yeah, what's up?
John, I got a question. How did Mr. G get?
because Mr. G is smart.
How did I get the equation? Well, if the center is 0, 0, then we know it's just x squared and y squared. And if it opens left and right, we know that x squared has to be positive. And we already knew that the distance from center to vertex was 4, so that's going to go underneath x.
Wait, how do you know it opens left and right?
Because they told you the vertices were on the x-axis.
How'd you find A, B, and C?
A is from center to vertex, so that's 4. C is from center to focus, so that's 5. And then B we found using the relationship C squared equals A squared plus B squared. Okay?
Alright, I got you.
You good?
What was B?
B was 3.
No, like why? Why did you say
Because when you set up the equation, 25 equals 16 plus B squared, you get B squared is 9.
Okay.
Nope.
Got it.
So B has to be 3. Okay, last one. Eccentricity is 5. So right away, you know what shape this is, right? I hope you're listening, because on the test you might see something like this. Find the equation of the conic, and it doesn't tell you which one it is, but you know from this that it's what?
Of a comic?
It's a
Conic.
hyperbola.
A hyperbola, because eccentricity is bigger than 1. Okay?
See, I got you.
Length of transverse, this also gives it away. Transverse axis is 4. Center is 6, negative 5. And the focal axis is vertical.
Are we going to do any other shape besides what we already done?
No. Yeah, circles, parabolas, ellipses, and hyperbolas. Yes,
If eccentricity was 1, what would it be?
parabola. Very good question. And if you think about it, right, focus. It's the ratio of C over A. For a parabola, that distance is exactly the same. You know what I mean?
What if it's 0?
Wouldn't be a conic then.
What would it be?
Something else, a point. Okay. If the center is at 6, negative 5, so here and down here somewhere, so this is my center. Focal axis is vertical. What does that mean?
Up and down.
The foci are located up and down. Does that make sense?
So they open
So this tells you that the hyperbola opens up and down, which then tells you that if the center is at 6, negative 5, what's the first thing that we know? What's the first term?
So y.
Y
minus
Minus plus 5.
plus 5.
plus 5 squared over something, which we'll find in a minute, minus,
X minus 6.
good, squared over the other one equals 1. Okay. Length of transverse axis. That's equal to 2a. And if 2a is equal to 4, we know a is 2.
That means
So that means that
It's over 4.
over 4 for the y, right? Because a is always with the one that's positive. And now, since I know eccentricity is 5, how do I find eccentricity?
2b.
C over a. And that has to equal 5. C over, what was A? 2 equals 5. So C has to be 10. That doesn't help me yet.
But you plug it in the.
But now I could use, the other equation. So if C is 10 and A is 2, we know C squared has to equal A squared, which is 4, plus B squared. Sorry, I didn't plug in the C squared. What is C squared? 100. If you subtract 4, you get that B squared is 96. B is root 96, but when you plug it in, it's squared anyway. So this is the equation. Okay, now this is perfect because this illustrates the point that A is not necessarily the bigger one. You see that, John?
Yep.
Okay.
Seeing a picture. Oh, I thought it was.
I'm taking a selfie, actually.
That's
Where
right.
your bat.
Okay, that's it.
Farewell.
Farewell. Homework's day 5.
There's homework?